What is density? If we look at these two containers down at the bottom here in this picture, we have a Pepsi floating on top of the water, or Diet Pepsi floating on the water, where a regular Pepsi is at the bottom of the water. The containers are the exact same volume, but one happens to be floating. So is volume going to make a difference in our density? And what about mass? If we have the same exact mass of two objects, one of them can still float and the other one can sink. So one of the things that we have to consider is when we look at mass or density, we actually have to compare the mass and the volume. We can't just pick one of these to decide on. If you look at these two objects, on the left we have a piece of aluminum, on the right we have a piece of wood. And you all know from experience of putting a piece of metal in water, it tends to sink, and a piece of wood tends to float. Well, the relationship is, I mean, both of these have the same volume, but what's different is that one of them you guys would call heavier. You'd put it in your hand and you'd say, well, this is definitely heavier. It's this relationship down here at the bottom that says, you know, the density of aluminum is 2.8 grams per centimeter cubed. So if we measured the length times width times height, we'd get the volume of this. And for every centimeter of this object, it would weigh 2.8 grams. If we look over at the wood, this is a piece of oak. That oak has a 0.7 grams per centimeter cubed. So for every centimeter, we just have less weight. And the standard for all of these is water. And water actually has 1 gram per 1 centimeter cubed, or 1 centimeter cubed is also considered to be a milliliter. And so when we start to explore some of this, we're going to pay attention to that 1 centimeter cubed is also equal to 1 milliliter. So when we're doing calculations on density or even on volume, we need to pay attention to that relationship. So here's one of our problems. How do we determine what metal we have? So if you look down the left-hand side, we have iron, which has 6.98 grams for 1 milliliter, copper 8.94, aluminum 2.65, and zinc 7.14 grams per milliliter. Well, we have this sample and it's gray. So one of the things that we can eliminate right away is copper is a red color, but iron, aluminum, and zinc all have a gray color to them. So what we have to do is we have to compare the volume and the mass to see what the density might be. So notice over here our units are grams over milliliters. So we want to do the exact same thing with this data set that we have. We have 176.6 grams in 25.3 milliliters. So what we're going to do is take 176.6 grams and we're going to divide it by 25.3 milliliters. And what that's going to do is going to give us a value that we can use to calculate, or actually calculate a density, and then we can compare that density against these known densities and see if we can't come up with one of them to determine what metal we might have. And so if I grab a calculator here real quick, we're going to take our 176.6 divided by 25.3, and we come up with we come up right on 6.98 grams per milliliter. And so we know that that substance is going to be iron. Okay, and we can figure this out. I could give you a handful of substances, and the two things that you have to find out about all of them is you have to find volume, you have to find mass, and then we can compare it against the knowns to determine what substance it might be. One of the ways we can figure out volume if we have an irregular shape is by water displacement. What we do is we fill up a graduated cylinder, and you notice we have one on the left here. Fill the graduated cylinder to a known volume. So this is actually about 3.4 on the left-hand side. So we got 3.4 milliliters before we start. Okay. Then what we do is we take our object, we got our little guy here, and we drop him into the graduated cylinder. The amount of displacement, or the change in volume here, is how much he occupies. And if you notice, it comes up to 5.0. So we know that our volume initial, VI, is equal to 3.4, and volume final, VF, is equal to 5.00 milliliters. So if we want to calculate his volume change, we have this equation up here that says delta V. Anytime you see delta this year in class, delta simply means change. So we have the change in volume is equal to the final volume, so VF minus volume initial. And we come up with this object is 1.6 milliliters. Now, to mass something, what we'll do is just take it to a balance, set it on the balance, and we could get the mass. So how can we use density? As we start to explore with density, we can determine purity of substances. We can determine, one of the old ancient ideas was people would make brass or bronze and pawn it off as gold. Well, if you understand density, you can understand that the volume to mass ratio for gold is very high, and brass and bronze, copper and zinc combination is significantly lower. And so we could determine that we wouldn't have gold actually. And but when we're figuring out, so here we have pure copper, and if we know the density of copper, in fact, we'll flip back and look at it real quick. We have 8.94. So we got this 8.94 grams per milliliter. Now, if I had 20 grams of this substance, I could actually figure out what volume it should displace. And so the way that I look at this, and hopefully I can grab this little guy and get it out of our way. There we go. If I take that 20 grams, so I start out 20 grams, I want to get rid of grams. So what I do is I say, well, I want to get to a volume. So my grams go on the bottom, my volume goes on top. My relationship between volume and mass is this 8.94 for 1 milliliter. So I just put 1 milliliter on top, my 8.94 on the bottom, and what's going to happen is those grams in either case are going to cancel out for us. So if we draw a line through those, we're left with milliliters. So again, we take our calculator, we take our 20 divided by 8.94, and we come up with a volume of 2.24 milliliters. So what that means is if we have 20 grams of copper, we should have 2.24 milliliters, which is actually a fairly small amount. Well, this is the density video, and we will be doing a density lab to explore this whole idea and try to figure out some of the unknown metals.